Part 2 is a 3-bit decoder. All right. So 3-bit.
Sir, sir, or the part one, where will we get the LEDs from?
Oh no, you don't have to get any LEDs. You just have to synthesize 7 functions. So each so you have to design the functions so that they light up the LEDs correctly. You don't have to get the LEDs. All right.
Yes, sir.
So this one is a 3-bit decoder.
Sir,
3-bit,
so what type of functions we have to add? Like all the LEDs should run independently?
yeah. For example, if your code is 0, all
Yes,
right,
yes.
then which LED should light up? So LEDs A, B, C, D, E, F should light up. If your code is
Why,
1,
sir?
well, because then it will look like a 0. Simple.
Okay. Got it, sir.
Ah,
It is a calculator digit. Okay, sir.
yeah. So if it is 1, then you should light up B and C. So like that. All right. So that's now a k-bit decoder has 3 input lines to enable 2 to the power k outputs. Okay. So you have a 3-bit decoder. All right. So again, uh, decoder is so a decoder works like this. So I mean, there's just a box. All right. So you have got 3 input lines and 8 output lines. Okay. So if it is all 0, this one lights up. If it is 1, means, so this is for 000, 001, like that. 111. So this is a decoder. Now, what's a 1-bit decoder? So this is 0, this is 1. All right. This is 0, this is 1. So, and all right, this is 0 and this is 1. And you can also have, so what happens is, you can make a, so you can have a tree structure. Okay, you can have a tree structure. Or maybe I can move this a little bit. All right. So you can have. So this is say. Sorry. All right. So this is say x0, x1, x2. All right, so you see that you have a total of 8 lines here, and over here you have got, this one is perfect, clumsy. All right, so you have got 8 lines here. Three lines here. So this one is device enabled. So this is this is the enable line. So your truth table is, and this is your say x, and this is, let us say y0, y1. So what's your truth table like? So if enable is 0, both are 0. So this one is don't care. If enable is 1, this is 0, then y0 is 1, y1 is 0, if it is 1, alright. So this is how your, this is the function of the 1-bit decoder. Alright. So each one is a single bit decoder here. So you can construct a 3-bit decoder using these 1-bit decoders like this. Alright. So this is a 3-bit decoder. So you can now 3-bit ECC parity generator. You have already seen how that is done. We have seen that in the morning. Alright. Yeah. So then 1-bit ECC. Okay, so this is that 1-bit ECC. So these two are actually the same modules. You know, this one and this one. These are the same modules. So this one is recomputing the parity, and then this is the ECC. So the working of the ECC also was explained. So now you can, you can correct. Assuming that there is only 1-bit error, you can correct that error. All right, you can correct that error, and then you have a test setup. So this is your basic system. This LED, you actually don't have this LED. Instead of this, you have got 7 functions for ABCD up to F. All right. And finally you have this test setup. So this test setup, this one, so you have got a total of 7 lines, right? You have got a total of 7 lines. All right. You have got a total of 7 lines, and you would like to introduce error in each line. All right. So how do you introduce an error? So that is shown over here. This is your XOR. So this is your actual data, and if you want this data to be flipped, so you make E1. So basically what you have is, these are your data lines. So you have got, and for each one you are putting an XOR. All right. For each one you are putting an XOR. All right. You are putting an XOR. So this is, let us say, well, you have got those, you have seen in the morning. So you have got total of 7 lines, 4 data lines. And in the slides, I think those are called D1 to D4 and P1 to 3. Okay, so total of 7 lines. All right. So now you have a decoder. All right, 3 to 8 decoder, and you have got, well, you got 8 lines, but you need only 7 of those. So now you might like to, so 0. So 0 means, let us say 0, whatever. So you have got 0 to 7. Okay, so you can choose one of these. Say 0 might mean no error. Okay, one means this is 1 error in line 1. Say 2 means error in line 2. So 7 means all right. So 0 means no error. So all of these are 0. 1 means, let us say, one of these lines is 1, then the next one is 1, and so on. So in each of these cases, ECC should work. All right. So that is basically what your experiment is about. So as you can see, there are many modules. So as we have already told you, you need to divide the work among yourselves so that the experiment is so that you are able to share the load properly. All right. So that's what this experiment is about. So any questions? Hello?
Sir, what are we expected to write in the lab report? If,
you write something about some theory of error, how it works and all that. So once you have done the experiment, you will have something to write. All right. So.
But the main focus is about building the circuit, right?
Yeah, building the circuit, but you should also document what you have done, right?
Yes, sir.
So that is what you got to put in the report. All right. So that is the experiment. So you can go about doing it. Do you have any questions? All right, then I'll leave you to get on with the experiment. I'll close the. I will leave now. All right.
Can you extend the deadline till 7th Feb? It's written the deadline is 3rd.
Deadline, yeah, so, oh, yeah, sorry. No, one second. Yeah, it will be 7th. Yeah, sorry, no, 1 second. Today is 31st. Today's 31st. Oh, yeah, it will be February 7th. Oh, yes. So I'll just change the deadline. Yeah, that's fine. I'll change the deadline to 7th Feb. All right. Anything else?
Sir, one question. So regarding assignment 2,
in that the way you said to do the component thing, I mean I'm doing it, but when I'm loading it, it is crashing multiple times.
No, yeah, it should work because I had shown you how to load the component. It should work because
Yes, sir.
this.
Actually, it is crashing whenever
So
we
it is
try to
crashing
move it.
a lot of times. From half ladder, we are going to full ladder, and then when I'm loading full ladder, it's crashing. Somehow, if I even manage to make a ripple ladder, then if I even try to use the ripple ladder by loading the component, it is crashing every time. So I am not
All
able.
right, okay. I'll do one thing. I'll just check it up. So I'll just check it up and get back to you. So I think I'll have to get back to you on Wednesday only. All right. So I'll check it up.
So, but the submission is today, so that is why we are in a pain, sir.
No, it's okay. We can extend the submission deadline if required. Yeah. I'll check it up and get back to you. Okay.
What will we submit today? I mean, today we have to give something. Right?
No,
No,
if
we'll
you
extend the
if
deadline.
there is a
Okay,
problem, if you have not been able to do the experiment because of that reason, you can just hold on for some time. I'll extend the deadline. If you have not completed, then I'll just extend the deadline. I'll check it up and extend the deadline by a few days.
okay, sir.
All right.
Sir?
Okay.
Somebody says that if you change the JDK, if you take JDK 11, it's working.
Yeah, I got JDK 11 in fact. So
I think most people are using JDK 17.
Sir,
yeah,
then
that is
please
another.
tell which specifications. I mean, of course, we will like
Yeah,
when we download it, we download 7.
because I got JDK 11. I think that's the best thing. So why don't you? So anyone has succeeded doing it with JDK 11? Anyone present here who has succeeded in doing it with JDK 11? Hello.
Yeah, I think Aman Sharma has done it.
So is Aman Sharma here?
Sir, I was just able to figure it out before the class. I just like tried it
No,
in.
it's okay. So if you have done it, yeah, so actually that could be a problem because as I told you, this is not that robust. So it has been tested. I have in fact tested it with JDK 11.
So JDK 11 is working in my case.
So just try it out with JDK 11, and if you are able to do it, I will extend the deadline by 1 or 2 days. So first you do it, and then on Wednesday you can inform me whether it's working with JDK 11. All right.
Sir?
Or you can just message me, whatever.
Sir?
Yes.
Sir, sir, also if I load the component, so it becomes very difficult to identify that which terminal is what. Like even after I have named it, that no information appears.
See, what we will do is that we will extend the deadline.
Oh, yeah.
So don't
So
worry about that.
you first check that it's working, then we can extend the deadline. Yeah. All right. Okay, then.
Sir,
with 11 also it is
as
crashing
till now the
in my system.
work. Yeah, exactly, sir. Because it's crashing till now, can you at least confirm at least 1 or 2 days extension? Because it's causing a lot of unrest, as most of the circuits have been crashing and incomplete.
Yeah, so that's what we are telling you. Check it out with JDK 11. You can give some feedback whether it's working, and we'll.
No. So we are definitely extending it so don't panic. We are extending it by 1 or 2 days, but you try. I mean.
Okay, sir. Noted.
No need to panic.
Sir?
Okay, then. Anything else?
Sir?
Yeah.
Sir, as I was saying that I can load the component and it's working also, but it's difficult to identify which terminal is what. So is there any way to understand?
So there actually, that one. I think the inputs are identified. It is a little, you just do one thing. You just test out a small component with say 2 inputs and 2 outputs. Just figure out how the mapping is taking place, and then you go by that. Yeah. There's a little bit of trial and error over there. Yeah. So once you do it for 1 or 2 components, then you will know how to do it. So just try it out for, just design some small component and check how it is happening. Then you will get you will understand how it is working. All right.
Okay, sir. And also, sir, in the last question of the assignment 2, where we have to convert from binary to BCD, we can do that by adders also and also by truth table. So, is using adders mandatory in that question?
It is not really mandatory. You can, if you want, you can do it by truth table also. No problem.
Okay, sir.
Binary
Thank you, sir.
to
XS3, sir.
binary to BCD. Yeah. Okay.
Not BCD, sir. Binary to XS3.
Binary to binary to XS3 you can, but you will essentially be realizing that adder only. Anyway, so you can do it one way or the other. Yeah.
Sir, so we can use ripple adder in binary to XS3, right?
Yeah.
Okay, sir.
All right. Okay. All right then.
Sir, one question. Even if we implement the binary to XS3 and XS3 to binary using truth tables and all, we will still have to make the half adder, full adder, and the ripple adder, right?
Yeah, actually, if you use the adders, it is the design becomes quite simple. Yeah.
So we are facing one more issue. Like, so we are facing an issue that when we create a component, then after that the terminals are not assigned as we in the order we have labeled them. Like it is being
That's what I just mentioned some time back. That there is a little bit of trial and error involved. You design a small component with, let us say, 2 inputs and 2 outputs, for example, the half adder, and just understand how the mapping is happening. Then you'll get the hang of it. So the order in which you name the terminals, I think that determines the order in which you will get those pins.
Sir, that is what I'm saying. That is not happening. We did that.
No, it will not happen. So what you have to do is that you try out for small circuits. Okay, and then see what is happening.
Random allocation to pins, then there is no issue, right? We can just make it out from like if the circuit is working fine, then it is fine, right?
Yeah, as long as it is working fine, it's fine.
Yeah, but you will need to use components. For example, this experiment, you will need to use components. So you have to just do a little bit of trial and error and figure out. Okay.
Okay, sir.
Okay.
Sir, for figuring out the circuits, we can explain it with K-maps, right?
No, you don't go into K-maps. Just truth tables will be enough.
Sir,
no need to minimize. See, if you minimize, it becomes difficult to understand what is happening. Okay. Don't try to minimize.
Okay, sir.
We will go into minimization later. Yeah.
Okay, sir. Understood.
All right.
Okay.
All right. Okay.
You can message us. If you have any doubt, you can message us in MS Teams. You try it. Once you try it, if you face any problem, you message us. Okay. Bye.
Okay then. All right. You carry on with the work then. Yeah. We'll leave now.
Thank you, sir.